All right, so this is part 2 of graphing linear inequalities. If you're coming to this video first, you'll want to go back and watch part 1. Remember, when we're graphing inequalities, you're going to graph the line just like it were an equation first, okay? And then we're going to determine if the line is dashed or solid, okay? And then we're going to determine which side of the line do we shade, okay? All right, so let's go on down to number 3 here. So notice these inequalities are in slope-intercept form. We've already got y on a side by itself, okay? So remember the quick graphs for that. We've got our slope, we've got our y-intercept. So we're going to graph the line first using that quick form, okay? So remember, my slope is -1/2. My y-intercept is +3, okay? So I want to graph that line first, okay? So do that right now. We're going to go to Desmos in a second just to verify the work, but I'm not going to graph here. I'm just going to use Desmos, okay? Next thing we want to determine, is the line dashed or solid? Okay, so because it's less than or equal to, I'm going to have a solid line, okay? Now, it's not as easy as the inequalities in the first part, because I actually have to test values here. I can't just, look at the line and tell if I'm shading to the left or the right or on the top or on the bottom, okay? So I actually want to test the origin, okay? This line doesn't go through the origin, so I can test the origin, okay? If the origin is a solution, then we're going to shade that side. If it's not, then we're going to shade the other side, okay? So I'm going to go ahead and show us testing the origin right here. So I'm going to plug 0 in for x and 0 in for y. Okay, notice I plugged in 0 for x here and 0 for y here. And that leaves me with 0 on the left side and just a +3 on the right side. So I need to ask myself, is 0 less than or equal to 3? The answer is yes, okay? So that checks out. So once I've graphed my line, I'm going to shade on the side that the origin is. Okay, so let's go to Desmos now, and I'm going to plug this in. Y is less than or equal to -1/2 x plus 3. Okay, so y less than or equal to negative, I'm going to call it 0.5 x plus 3. Okay, so you can see I've got my y-intercept of 3, my slope of down 1/2, down 1/2, down 1/2, okay? And then notice the origin is here. It's part of the solution. So notice that I'm shading on this side, okay, because the origin was a solution of the inequality. If the origin weren't a solution, then I would have shaded up here, okay? But that's not the case. So this is what your graph should look like, and you should shade below the line and to the left of the line, okay? All right, let's take a look at the next one. All right, we've got y is greater than x minus 3, okay? So we're in slope-intercept form again. Remember, my slope is +1. There's not a number there, but remember the slope is 1. My y-intercept is -3. So go ahead and graph that line now. But remember, the line has to be dashed, okay? Because the inequality symbol is just greater than, okay? So we're going to plot our y-intercept here at -3. We're going to go up 1 and over 1 multiple times, and I'm going to draw a dashed line through there, okay? And then I want to test the origin, okay? So I'm going to plug in 0 for x and 0 for y, okay? So I'm left with 0 is greater than -3. Is that a true statement? Yes, 0 is bigger than -3, okay? So I'm going to shade on the side of the origin again. Okay, so y is greater than -3. Let's plug that in here. Y is greater than, it was y is greater than x minus 3. So y is greater than x minus 3. Okay, so again, y-intercept of -3, positive slope of 1, so up 1 over 1, up 1 over 1, okay? And then we're going to shade where the origin is. So notice we're shading above the line or to the left of the line. Okay. All right. Now the next two inequalities are in standard form. Okay. So I want you to try those on your own and then come back and watch the video to check your work. All right. So number 5, again, notice we've got inequalities in standard form here. We've got both the x and the y terms on the left side, and then we've got our inequality symbol, and then we've got a constant on the right side. So if you remember, the best way, the quick graph for these is to find the intercepts. Okay, so remember, when we're finding the x-intercept, we're just going to cover up that, and the x-intercept is going to be +4. Okay, again, think of this as an equation, not as an inequality at the beginning. The y-intercept, okay, I cover up the x, okay, and I solve the equation that's left over. So then the y-intercept would be -2. Okay, again, think of it as an equation when we're first graphing the line. Okay, next question, going to be a solid line because the or equal to is there. And then this line's not going to go through the origin, so I can test the origin to determine which side I need to shade. Okay, so we're going to plug in the origin 0 for x and 0 for y and determine if that's true or not. So that gives me 0 minus 0 is greater than or equal to 4. So that means 0 is greater than or equal to 4, and that's not true. Okay, so this time I'm not going to shade, okay, where the origin is. I'm going to shade on the opposite side. All right, so let's check our work with Desmos. X minus 2y greater than or equal to 4. X minus 2y greater than or equal to 4. Okay, so remember, our x-intercept was 4. Our y-intercept here was -2. The origin is here. Okay, don't forget solid line. The origin is here. We determined that was not a solution, so we're going to shade on the other side. Okay, so that's the answer for that one. Okay, one more, number 6. All right, 3x plus y is less than -6. So remember, our x-intercept, think of this as an equation, 3x equals -6, so the x-intercept would be -2. Y equals -6, so that means my y-intercept is -6. All right, so we can go ahead and graph the line there. Notice it's going to be a dashed line because the inequality symbol is less than. Okay, and now we're going to test the origin, and we know all this other stuff. Okay, so let's plug in the origin, 0 here for x, 0 here for y. Okay, that leaves me with 0 plus 0 is less than -6, and that is not true. So again, we're going to shade opposite the origin. Okay, so let's go back to Desmos and plug this in. 3x plus y less than -6. So let's get rid of that. 3x plus y is less than -6. Okay, so again, you see I'm going to move this up a little bit. Okay, our x-intercept there at -2, our y-intercept there at -6. Okay, dashed line because the inequality symbol. We tested the origin, we found that didn't work. So that means all these ordered pairs over here would be considered part of the solution set. Okay, so that's how you graph linear inequalities. And what this is going to lead into is we're going to do systems of linear inequalities, and we're going to use that to do something called linear programming, which I think is pretty fun. Okay, good job.